Welcome to qnawire.
This is problem number 62 of the Stewart Calculus 8th edition, section 2.8. Part A. Sketch the graph of the function g of x is equal to x plus the absolute value of x. So one way we can interpret this, maybe we can rewrite it, because we have the absolute value of x in the function. We can rewrite it as an absolute or a piecewise function for two different functions where x is greater than or equal to 0, and one where x is less than 0. And we recall that specifically the absolute value of x can be x, is given as x when x is greater than 0, and is given as negative x when x is less than 0. Okay, so if this is true, x is greater than 0 means that the absolute value of x we're going to take as just x, so x plus x is 2x. And when x is less than 0 in this region, we get x plus negative x, meaning that the function g is equal to 0, which is in the region x less than 0. So we can sketch a graph knowing this information. We see that the function, or we plot the function as 0 up until it reaches the origin where it's equal to 0. For both cases, x equals 0, we get 0. So it's continuous, and then afterwards it goes into a linear function with the slope of 2 to x that passes through the origin, and this is our graph of g of x. Part B, for what values of x is g differentiable? Well, g is differentiable in this region here. We see that this horizontal line is a constant value, and for a constant horizontal line, the tangents are all horizontal and their slopes are 0. So it's differentiable everywhere here, where for x is less than 0. And for x is greater than 0, we have this linear slope, which is 2x, and all the tangent lines have a slope of 2 for this part of the function. So it's differentiable everywhere there. The only part where it's not differentiable is here at the origin, because there is a corner or a kink in the function. So it's not smooth. We go from a 0 slope to a slope of 2 immediately, abruptly, meaning that at x equals 0, it is not differentiable. So part B, for what values is x of x is g differentiable? All values except x is not 0. So x can't be 0. Part C, find a formula for g. Well, we just discussed the exact slopes of g. So find a formula for g prime. G prime are the derivatives of all the slopes of the tangent lines. So it's a derivative function of g, and we confirmed that the slope should be 2. All the tangent lines are exactly the same as this function 2x. All those slopes of those tangent lines is 2, because this is a linear relationship. So this is true for x is greater than 0. Thus, the derivative function is equal to 2. And then over here, the slopes of all the tangent lines are 0 because it's a horizontal line. So g prime of x is 0 for x is less than 0. And then we recall that x cannot be 0. It's not differentiable at x equals 0. So we don't include that in our domain for the g prime of x function. And this is exactly the formula for g prime of x. Another way, if we would like to rewrite our formula for g prime of x, is in the form 1 plus, and again, taking advantage of absolute value of x, or absolute values, we write it as absolute value of x over x. And we see here that as long as x is positive, this quantity is a positive 1, so we get 1 plus 1. And as long as x is negative, this quantity is always equal to negative x. Negative x over x is negative 1. 1 plus negative 1 is 0. So this is the same as this piecewise function, and both of these are acceptable answers.